In this video, we will be looking at inequalities in two variables. By the end of this lesson, you should be able to solve multi-step linear inequalities in two variables, algebraically and graphically. So that's where this lesson is different from our previous two lessons in this unit. All of our inequalities will have two variables. So let's take a look at what that may look like. In situation number one, you have two summer jobs at a youth center. You earn $8 per hour teaching basketball and $10 per hour teaching swimming. Your goal is to earn at least $200 per week. What is a possible combination of hours that will allow you to meet your goal? So let's take a look at writing this equation. So I have two summer jobs. So I'm going to earn $8 per hour teaching basketball. That can be X. And $10 per hour teaching swimming. There's my second variable, or Y. My goal is to earn at least $200. Remember that at least is greater than or equal to $200 per week. So let's write my equation. I'm going to make $8 per hour. Remember that per means multiplication, $8 per hour teaching basketball, and $10 per hour. Swimming is Y, $10 per hour teaching swimming, and I want to earn at least $200. Now this one here, it does say per week, so we're used to putting a variable there, but each of these, we earn that each week, so I want to earn $200 per week. So just because we see per doesn't mean we always write multiplication, but it is a clue that we may need that. Okay, so we have our equation here. How do we solve that when I have an X and a Y? So we're going to come back and take a look at this at the end of our lesson, but let's take a look at what some of these pieces mean. So when we have two variables, X and Y, okay? So graphs of linear inequalities include the graph of a line and a shaded region. So I have two variables. I'm not only going to have a line when I graph them, but I'm also going to shade. So the line can be solid, or it can be dashed. Notice the difference between those types of lines. We've only seen one like this before. We've only used solid lines. But sometimes with inequalities, it can be dashed. Just like, remember, when we looked at one variable, when we had less than or greater than, that was an open circle. I had less than or equal to or greater than or equal to, that was a closed circle. So similar to that, we're going to have solid lines and dashed lines. The shading can be shaded up or shaded down. So we can have shade up or shade down. So let's take a look at when this would occur. So if you notice here, I have Y is less than. So shade, I'm going to shade down for less than. I'm going to shade down for less than. My line is going to be, if you notice here, there's no underline. When there's no underline, remember it's like the open circle. The open circle is going to be the same as the dashed line. Okay. When I look here, I'm still going to shade down because it's still a less than line, but instead of being dashed, I'm going to be solid because I do have that underline right next to the Y. So that's the difference. They both shade down because they're less than, but the one without the underline is dashed, the one with the underline is solid. Here for this one, I have greater than, so I'm going to shade up. There's no underline, so my line is dashed. For my last one, I have greater than or equal to. It's still going to be shade up because it's still greater than, and the line here is going to be solid. So we wrote these as we went up. It's going to be greater than and greater than or equal to down is going to be less than or equal to. Solid line is going to be greater than or equal to or less than or equal to. And a dashed line is going to be less than or greater than. So it's the same combination as when we looked at it for inequalities in one variable. So let's take a look at what they look like. So in these examples, I have an equation and then the graph that represents it. Okay, notice here my y-intercept is 1. I have positive slope. I went up 2 and over 3. So there's my 2 points. Here I have less than, so there's my shade below. And I have a dashed line because it's not underlined. So here you see these points, 1, 1. So let's look at the point 1, 1. If we put that on my graph, notice that's in the shaded region, so that's a solution. Here I have -2, -4. I go -2 and down, 1, 2, 3, 4. Notice how it's in the shaded region, so that's a solution. All of my solutions are in the shaded region. So if you want to put a note here, solutions are ordered pairs in the shaded region. So let's take a look at another example. If we plot these points, 4, -3, 1, 2, 3, 4, down 1, 2, 3, and the point, so if we look at here, it's in my shaded region, it's a solution. -4, -5, go to the left, 1, 2, 3, 4, down 1, 2, 3, 4, 5. It's in the shaded region. They are also solutions. I have here -2, 1, -2, up 1. That one's in the shaded region. 3, 4. 1, 2, 3. Up 1, 2, 3, 4. Both of those are in the shaded region. They are solutions. Over here on the last example, I have -2, 0. -2, 0. This one just makes it. And that one is in the shaded region. And 1 over 1. 1, 2, 3, 4. Okay, so points that fall, ordered pairs that fall in the shaded region, those are your solutions. And notice here, if I have a solid line, that means I'm underlined. I have less than, I'm shade below. I have no solid line, so I'm dashed. I'm greater than, I'm shaded above. I have an underline, so that means I have a solid line, and it's greater than, I'm shaded above. So let's practice one. Let's take a look at example 1. Graph each inequality. So we are going to graph these. So we're going to graph just like we did earlier in the year. So we have to graph when we have it in this form. Remember, that is slope-intercept form. Which means I want to find my slope. And intercept means I want to find my y-intercept. So the slope of this line is the number with x. That's my -2. And remember, I wrote it over 1 if it was a whole number. My intercept, that's my y-intercept. So my b is the number without x. Now I'm going to go ahead and graph. And I always start with my y-intercept or my b. So I start at 1, 2, 3. And now I move my slope. So if it's negative, that means I go down 2, 1, 2, and I always go to the right 1. Down 2, right 1. Down 2, right 1. So I have a negative slope. I want to check that my graph looks decreasing, and it looks like it does. I'll check again once I draw my line. So now I want to look at my symbol here. The symbol that I have is less than. So less than tells me two things. I'm going to shade down because it's less than, and it is going to be a dashed line because there's no underline. So the first thing is dashed. I'm going to put a dashed line through these points. It is not going to connect. So there's my dashed line. And then I want to shade down. So down just means if my graph is like this, I want to shade below it. Here would be up, shading above the line, but I want to shade down. So all of my solutions are in this area. So we're combining a couple things. We're going to graph like we always have, okay, and then take a look at the inequality. That's going to give us more information, up or down, and dashed or solid. Okay, and be careful when you're shading. You want to make sure this goes on forever, but you only have to shade in the area that we have on our graph.